Why does the moon baffle scientists?
Because there is no self-consistent model or theory for its origin.
None?
None. They start with the assumption that there's no God, therefore they have to find naturalistic explanations for everything. Basically, none of them work. There have been 4 that have been put forward. The first one was called the fission theory, that the Earth spun so fast that when it was molten, the lump flew off and that became the moon. Second one was called the capture theory, that the moon was wandering through the solar system and ended up getting caught fortuitously in the Earth's orbit. Too much luck involved for that one. Then there's the co-accretion theory, that the same area of the protoplanetary disk formed the Earth and the moon, but there is too much dissimilarity between the nature of the rocks on the moon and the Earth. And the current one is the giant impactor hypothesis, that there was an impact from a huge Mars-sized object and that formed the moon. But there's no coherent, self-consistent model. But the Bible says God created the sun, moon and the earth, and that makes perfect sense.
What has lava on the moon got to do with Noah's flood? How did we get our moon? There's no satisfactory secular theory of how the moon came to be or its origins, and that baffles scientists. Dr. Mark Harwood, you worked in the aerospace industry for over 30 years, working on communications spacecraft. Why does it baffle scientists?
Good question, Matt. And I think the reason is that when secular scientists try and develop theories explaining the origin of something, they start with an assumption, which is they must use naturalistic explanations. So that means that by definition, they cannot even think about the possibility of a supernatural explanation. Now, if the supernatural is in fact the true explanation, then they're never going to come up with a theory that works. It's kind of like trying to find something by looking in the wrong place. If you look in the wrong place, you're never going to find it. The result is there is no self-consistent secular theory that explains the origin of the moon.
Okay, so before we dig into this anymore, there's one thing that's always intrigued me. Why do we only see one side of the moon?
That's a good question, because people have wondered that. In fact, I used to think, it's incredible that the moon spins on its axis in exactly the same time it takes for it to go around the Earth in its orbit. So one face is always looking at the Earth. Surely over time there'd be some drift, and you'd finally see the other side. And as I started to investigate that, I discovered that in fact there's a mechanism which kind of locks the moon, so one face faces the Earth all the time. It's called tidal locking.
Okay.
So what happens, it's a bit like this. The Earth, of course, exerts a gravitational force on the moon. The side of the moon closest to the Earth gets slightly stronger force than the side that's further away, because the force of gravity decreases inversely as the square of the distance between the two objects. So there's a slight stretching that happens on the moon. So it's not really a nice sphere. It's slightly elongated, a little bit like a football. Nowhere near that much, of course. So what happens is if the moon starts to try and turn away from facing the Earth, then there's a torque which gets developed because of that gradient, if you like, in the gravitational field, and it actually pulls it back. So the moon is kind of, if you like, held in that position, so one face always looks at our Earth. So when you look up at the moon at night, you're going to see the same face every single night.
I hope you're enjoying the interview so far. If you haven't already, like, subscribe, and hit the bell for notifications. Thanks for watching. And I hear a weird term sometimes. They even refer to it in Disney. What do they mean when there's a man in the moon?
Well, obviously it doesn't mean there's literally a man on the moon, although we have walked on the moon, which, by the way, I think is incredible, that the moon being the closest astronomical object to us, and we have actually walked on it, yet still we don't have a proper working theory for how it came to be. The reason we see an image like a man in the moon is because there are different cratering patterns on the side of the moon that faces us compared with the other side. And in fact, I've printed out a picture here so you can see what this is like. So over here, this is the face that looks at us, that we can see. And you can see these large dark areas, and they cover a pretty big portion of that face that's looking at us. over here, this is the side of the moon, the far side. Now, we had no idea what the far side looked like until we were able to make space probes that could go around the moon and photograph the other side.
Yeah.
So you can tell there's a pretty spectacular difference between the two, right? So what are these great big dark patches? Well, it turns out they represent massive impact craters of a scale that's way beyond the impacts that are caused here that produce these much smaller craters. So something like an asteroid or a meteoroid, a very large object, has crashed into the surface of the moon, shattered the surface, broken it so that molten magma can flow out from that and then become a lava flow over the surface of the moon. So as these large lava flows start to solidify, they set like basaltic rock, which is a black rock, and hence you get these very dark patches. But this is pretty amazing because it says that the moon has experienced a phenomenal barrage of huge objects.
Yeah, well, he looks like he's been punched up.
Yes, that's right. So the man in the moon is pretty sore, I reckon.
Yeah.
But I love this because it must have happened very, very quickly.
Okay.
Now, the moon turns on its axis about once every 27 days. That's how long it takes to go around the Earth.
Yeah.
So it's pretty slow. Just to make it simple, let's assume it takes 28 days. So it would go a quarter of the way in 1 week, in 7 days, right? So imagine these objects, whatever they were, hurtling towards the moon. They had to strike the moon in a very short space of time because the moon didn't turn much, right? It's just this area which has been hit. You can see there's very little here. There's one that you might argue is one here. By the way, these things are called seas, or the Latin for that is Maria. And when people first looked at the moon, they thought maybe it had seas and lakes on it, which is where that word came from. So these impact zones, or Maria, must have been there the result of a very short burst of impactors.
But this is on our side.
Yeah, this is on our side.
So why didn't the Earth shield the moon?
Well, it might have to a degree, but the moon is only shielded or behind the Earth for about an hour. So if you were to stand on the other side of the Earth, there's the Earth in front of us and here's the moon orbits, and as it passes through there, it's only shielded for about 1 hour. It's all it takes.
It's quite quick.
So that would be insignificant. It may well have had some effect like that, but not much.
Yeah.
So the result is we get all of this impact on this side, nothing much on that side, which says that the moon didn't turn very much in the process. Let's say, for instance, that this bombardment lasted for a whole week. So you'd imagine initially half the moon would be impacted, and then it turns through 90 degrees, and then you'd have another bit impacted. So in total, there'd be about 3/4 of the Earth's surface, of the moon's surface, impacted in the space of a week. But there's nothing over here, hardly.
Half, yeah.
So it must have been only a day or maybe 2 at the most, which is extraordinary because we tend to think of astronomical processes as being long and slow and distributed over millions of years and so on. And in fact, the secular view of this, what's called the late heavy bombardment period, is that indeed it was a very long drawn-out period.
So they don't agree with creationists in this regard?
No, they don't. Remember, they start with the assumption that we have to find naturalistic explanations for everything.
Okay.
In other words, there's no God.
Yeah.
So they're not interested in what the Bible would say, for instance, which tells us plainly that God created the sun, moon and the stars. So we've got this picture of this amazing, very short burst of massive impactors. And that leaves that pattern, which I can't actually do it myself, but somehow or other people see a face, but I can't get one out of it. Maybe in the Northern Hemisphere it's more obvious because in the Northern Hemisphere you see the moon the other way up, right?
Yeah.
It's upside down when you're in the Southern Hemisphere where we are.
So that sounds like a very quick and violent process. Is our moon a typical moon, or does it have any other special characteristics?
Oh, it's definitely atypical. There's no other moon like it in our solar system. For a start, the moon is very big relative to the Earth. It's about 1/80th of the mass of the Earth, and its diameter is about 1/4 that of the Earth's diameter.
Okay.
Now, of all the planets in our solar system that have moons, they've all got more than one. Mars has 2, Jupiter has 95 confirmed at the moment, and there's some work being done to see if in fact some more recent finds turn out to be legitimate moons or not.
Yeah.
And Saturn has 274 moons,
Wow.
128 of which were confirmed just in March of 2025.
In March?
In March. So what that means is they basically doubled the number of confirmed moons in one fell swoop.
That's pretty impressive. I didn't realise our moon was so unique in the fact that we only have one and other
Only
planets
one.
have many.
And it's very big,
So, okay.
right, compared to all the others.
So it's big, and we only have one. Are there any other unique features that it has?
Well, one really fascinating thing is that the moon is about 400 times smaller than the sun,
Yeah.
but it's 400 times closer to us. So that means when we look at the moon in the sky, it has a certain size, but so too does the sun. So that means you can have a situation where the moon obscures the sun. In other words, a total solar eclipse.
Yeah.
Now, total solar eclipses, I think, are absolutely fascinating. I've experienced one, and it was really, really something else. We travelled some distance to a different part of New South Wales and set ourselves up with cameras and telescopes and all the rest of it.
Yeah.
And guess what? It was a cloudy day.
So were you able to observe anything?
Well, we couldn't see the sun. It was a real shame. But you get to experience the effect, and it's really quite chilling. All of a sudden, and it's quite quick, the light dims and it goes dark. And as it goes dark, there's, of course, no heat coming from the sun. So the air gets cool and a wind immediately springs up. All the birds start to roost, very confused what's going on.
Oh.
And it all lasts for about 2 minutes, and then it starts to get brighter again, warms up, the breeze stops. It's quite uncanny. I can imagine how people groups, in years past would have gone absolutely ballistic when this happened. They'd have no idea what was happening. Sheer panic.
Yeah. I mean,
Yeah. So, the eclipse is really something. But it's like God has given us an invitation to discover things about the beauty and the wonder of his creation, because from total solar eclipses, we've discovered what's called the corona around the sun, the outer atmosphere.
and what's the corona?
Well, you can't easily see it in normal times because the sun's too bright, but it's an extremely hot, like outer atmosphere of the sun.
Yeah.
The element helium was discovered through a total solar eclipse. In fact, the name helium comes after a Greek god called Helios, the sun god. Another interesting thing was Einstein's theory of general relativity was verified during a total solar eclipse.
Wow.
And the way they did that was, and what was predicted by Einstein was that light would be bent in an intense gravitational field. Mm-hmm. And they found that when the sun was eclipsed, you can see the stars around the sun, right? And there were stars that were visible which should not have been. They should have been behind the sun. So their light was coming past the sun, bending and coming to us.
Incredible.
So that demonstrated a prediction of Einstein's general relativity theory.
And I understand the ocean tides are caused by the gravity of the moon. And you stated that it takes a whole day for it to circulate the Earth. But why do we have two tides?
So let me just clarify that. The Earth, I mentioned earlier, has a gravitational gradient over the moon, which is why the moon is tidally locked. But the reverse also happens. The moon puts a gravitational gradient over the Earth.
Okay.
And that has the effect of drawing the ocean waters on the side closer to the moon, so they bulge upwards, and also on the other side they will bulge upwards. So as the Earth rotates, you will experience two high tides and two low tides with every rotation of the Earth, which is a day. Now, it's a little bit longer than a day because by the time you get back around to where you were before, the moon has moved a bit in its orbit.
Yeah.
So the cycle of low and high tides takes actually 25 hours. You get two in each. Now, if you've ever gone fishing and you've checked the tides, you'll realise that the time of high tide actually progresses each day, a little bit later every single day.
Yeah. So do secular scientists have any suggestions as to why our moon is so different than any other in the solar system?
Well, here's a good question here, because the secular scientists have had a number of different models for how the moon might have formed over the years.
Yeah.
The first one of those was actually proposed by George Darwin, who was Charles Darwin's son. And he was an astronomer, and he argued that maybe the Earth spun so fast in its early molten stage that a lump flew off and then condensed and became the moon. It's called the fission theory.
And did it work?
Well, no, it doesn't explain the observations, because if that was true, the moon would be in the equatorial plane of the Earth. But it's not.
So it's in the wrong place.
It's in the wrong place. The moon's orbit is tilted with respect to the plane, the equatorial plane of the Earth. So that one didn't last. And also the Earth couldn't have spun that fast and still survived. It would have all flown apart. So nobody accepts that theory today. Then there was one that was called the capture theory. And the capture theory suggested that maybe the moon was wandering through the solar system and it got caught in the Earth's gravitational field and captured there, and now it orbits the Earth.
Brilliant.
Now, this is a very long bow. Now, I worked in the aerospace industry, as you observed at the beginning.
Yep.
Now, communication satellites, like the ones I was involved in designing, have to orbit the Earth directly above the equator at just the right distance, about 36,000 kilometres altitude, so that it takes 24 hours essentially to go around the Earth, the same rate that the Earth rotates. So the satellite appears to be fixed in the sky. That means you can have very cheap, simple antennas, and you've probably seen them on rooftops, little dishes pointing up at the sky. Yeah. You don't have motors on them to track all over the place. They just look at one place. And the reason they look in one place is the satellite's basically fixed with respect to the Earth.
I didn't realise.
But it's orbiting right now. To get it into that orbit is quite a challenge.
Yeah.
So the satellite itself has a number of rockets on board, rocket motors, and you've got to fire them in a particular sequence to get the orbit to be nice and circular and to be in the right inclination, in the right plane. And we spend some time and effort, of course, in planning those manoeuvres and making sure they're conducted well. And if you do it well, you get lots of spare fuel and therefore lots of life for the satellite. If you don't do it well, you shorten the life of the spacecraft. So
that's
not good.
Expensive.
So think about that in the context of trying to get the moon now to end up in an almost perfectly circular orbit around the Earth.
Okay.
You don't have rockets on this moon to control it, to fix the orbit up if it turned out to be very elliptical, for instance. And if we send a space probe to another planet to orbit it, for instance, we have to slow the thing down with retro rockets to get rid of a lot of its kinetic energy, so it will in fact be captured by the orbit. So to get the moon to wander randomly through the solar system and end up in a nearly circular orbit around the Earth is a big ask. Possible perhaps, but extremely unlikely. To the point where people started to think, well, maybe there must have been a third body present somewhere, which had the effect of slowing the moon down enough to get it to fall into the Earth's gravitational field in the orbit that it's in now. Trouble is, you can't see that third body now.
Okay.
So it's a kind of it's wishful thinking.
And none of these theories are accepted.
Well, that was in question because one of the motivations for the Apollo moon mission was to sample rocks for the moon to understand more about the nature of the rocks and therefore the geophysical and geochemical properties of the moon. And along with that capture theory, by the way, there was another one that was current, and that was called the co-accretion or co-creation model. And the theory there was that the same sort of swirling cloud of dust and gas that formed the sun and the other planets and formed the Earth also formed the moon.
Yeah.
So it all would have happened together very slowly, gradually over the assumed millions and millions of years of evolutionary history. Now, when the Apollo spacecraft ended up on the moon landers, they sampled rocks and then they brought them back, and scientists then started to analyse the rocks.
Yeah.
And they really wanted to know which of the capture theory or the co-creation theory or co-accretion model was the best one. Yeah. But neither worked. And it was interesting, the capture model was really eliminated because it turns out the rocks on the moon are quite similar, not exactly the same, but quite similar to rocks on the Earth. So the chance of something coming from some remote part of the universe, randomly entering the solar system, being captured by the Earth's gravitational field and having almost the same kind of rocks as the Earth is just getting ridiculous. I mean, it's hard enough to get captured into a nearly circular orbit, let alone be almost identical to the Earth, right?
Yeah, of course.
So they just said, that's too hard, that's just too lucky. So that one didn't make it. And then they looked at the co-accretion model and they thought, well, if they accreted from the same cloud, this cloud of dust and gas, the protoplanetary disk or whatever they call it these days, then you wouldn't find much difference between the Moon's rocks and the Earth rocks. But there are very important differences. Yes, they're similar, but they're different in significant ways. One of which is that the Moon has very low iron content in its rocks. And there's no real reason or explanation for how that could be. And so basically they were faced, and also there's a whole bunch of problems. The orbit parameters, again, for the Moon are a problem for the co-accretion model. And in fact, the Apollo missions really defeated both of those models. So they really didn't have anything much. Now, after the Apollo missions and that, they were in their late 60s, early 70s, there was a conference held on the origin of the Moon. I think it was held in 1984, if I remember correctly. And they came away from that concluding that a model called the giant impact hypothesis must be the right one.
Okay, explain more. What is this?
Well, back in the 1940s, somebody came up with this idea that maybe the Moon was formed by an impact with some other object in its early molten stage, and the debris from that formed the Moon.
Sounds plausible.
Sort of, but it wasn't really considered as a likely contender. It was such a long bow to draw.
Yeah.
But after they'd eliminated the capture theory and the co-accretion model, it was really the only model left standing.
Yeah.
So at this conference, they concluded that it must be the most plausible model. So there's been an enormous amount of work done in the last, 40 or something years to make this giant impactor model work. And that's the popular one. That's what you'll see if you jump on the internet and say, how was the Moon formed? It'll tell you some Mars-sized object called Theia crashed into the Moon in its early stages, and the debris formed the Moon, and the Earth sort of recovered, and now we've got this lovely Earth-Moon system.
And does the model work?
Well, not really. In fact, and that's not what you're going to find if you dig into this on the internet, right? They'll tell you how, there's some wrinkles we haven't really worked out yet, but we're getting there. It's a research project. But what gives it away, I think, was a lovely quote from a world-leading planetary scientist who once said, half joking, but he said, because there are no good explanations, the best explanation is that the Moon is an illusion. So, I mean, that's an admission that this doesn't really work, guys. We've got a problem.
Yeah.
So there are a number of reasons why the giant impactor model has got problems. And there are quite a few. Now, depending on how you model it and the angle at which which Theia strikes the early Earth, you get different results for the likely geochemical properties of the Moon. One model, the sort of standard one, which is like a 45-degree hit, would say that the Moon should consist mostly of the impactor's material. But the Moon is very similar, in the rocks are, to the Earth. So it's pretty hard to imagine how Theia would just circumstantially have had very similar chemical composition to the Earth before it hit.
Yeah.
If you change the angle of incidence, you get a different relationship. It says, oh no, the rocks on the Moon should be more like the Earth. And so depending on the assumptions you make, you get different results. But here's the catch. There is no self-consistent model. In other words, they can't solve all of the challenges. Like, how come the Moon's got the orbit parameters it has, 5-degree tilt and all this, nearly perfectly circular? Why is there only one Moon? The impact would have sent debris everywhere. Just imagine how vast, how powerful this would have been.
How many moons we could have.
Well, exactly. Every other planet's got multiple moons, so why have we got only one?
Yeah.
And look, there are numerous problems that you can't make them all fit. You can set the initial conditions in the model to solve one, but then it doesn't work for another. So there is no self-consistent model in the secular realm for the origin of the Moon. So it's a profound problem, hence the joking comment, maybe it's an illusion.
If you're enjoying this interview so far, you might be interested to know that we also produce the world's most widely read magazine on the creation-evolution debate, Creation Magazine. It's packed with beautifully illustrated articles showing how real science supports the Bible. It's designed for the whole family and is a great tool for strengthening your faith. Sign up now to receive 4 issues per year. Follow the link in the description.
So if there's no naturalistic explanations, are there any supernatural?
I believe there definitely is, because God in his grace has given us his word, and that tells us exactly what he did. Let me read. And we find it in the book of Genesis, of course, which is the book of beginnings, and reading from verse 16. In fact, I'll read from the beginning of the activities of the 4th day of creation, which is when God made the sun, moon and stars.
Yeah.
Verse 14. Then God said, "Let there be lights in the expanse of the heavens to separate the day from the night, and let them be for signs and for seasons and for days and years." So God is explaining why he's making the sun, moon and stars. There's a purpose behind it. "And let them be for lights in the expanse of the heavens to give light on the earth, and it was so." In other words, it happened just as God said. "And God made the two great lights, the greater light to govern the day," that's the sun, of course, "and the lesser light to govern the night. He made the stars also. And God placed them in the expanse of the heavens to give light on the earth, and to govern the day and the night, and to separate the light from the darkness. And God saw that it was good." So there we have in the book of Genesis an explanation of the fact that God did make the sun, moon and stars, and why he made them. And that makes eminent sense, because if God had created them intentionally, purposefully, you would expect to find evidence of that intention and purpose in what we observe. So what did we observe? Well, it's a very special moon. It's big compared to every other one. The size is just right to block out the sun to give total solar eclipses. It causes tides on the earth, which flushes the coastal waters, oxygenates the water so that coastal ecosystems can thrive. In fact, one benefit that I didn't mention, it's a wonderful aid if you're out on a date and looking to impress someone as the moon rises in the sky.
Yes, it is. So this seems like a very short time, though. You said it happened in one day, but was that recently? Was it a long time ago? We hear about the Big Bang and that it was billions of years ago. Is that still the case, or is there any evidence to suggest otherwise?
Well, the Bible very plainly says that God created in just 6 days. It didn't take billions of years.
Okay.
And not only that, in later chapters, particularly chapters 5 and 11, there's a list of the people and their sons next in line, fathers and sons and so on. And the age of the father when the son next in line is born is given. So if you add all the numbers up, it actually gives you a beautiful way of determining the age of the earth.
So you can track the age of the earth
It's
through
all
genealogies?
documented there in the book of Genesis. So that takes you from the creation to the time of Abraham, which is about 2,000 years.
Yeah.
From the time of Abraham to the time of Jesus is about 2,000 years. We know that from history and from scripture. And of course, from the time of Jesus to the present day is about 2,000 years.
2025.
So 6,000 years approximately, according to the Bible, is the age of the universe from creation to the present day.
So the Bible says there's only about 6,000 years since creation. Is there any evidence to suggest this short time period?
Well, there's actually heaps of it. And look, I'd refer people to a wonderful article on our website that's called The Age of the Earth, and you can find it at creation.com/age. And it lists 101 evidences that show that the Earth and the universe is actually young.
101.
101 is more than that. It just sounds good. That's why we put it in the title.
All right.
But
Catchy.
if you think it is, and it's a great article, I recommend it. But if you think specifically in the context of the moon, there are several really interesting lines of evidence to show that the moon can't be old. It must be young. Now, we talked about the Apollo missions before, sampling rocks. One of the things the Apollo astronauts did was to leave what are called corner reflectors on the surface of the moon.
Yeah.
Now, corner reflectors are like the cat's eyes on the road at night. You know, you're driving along, your headlights strike these things and they reflect straight back to you.
Yeah, so you can see it.
So they consist of 3 little mirrors or reflecting surfaces that are all at right angles. And any light that enters a corner reflector leaves the corner reflector in exactly the same direction from which it came.
Okay.
So as you drive, the light from your headlights hits the corner reflectors on the road and you see them. Now, that means that scientists now can fire high-powered lasers at the moon onto these corner reflectors and get a ray that comes straight back.
And what's the purpose of that?
Well, we can measure the distance between us and the moon with
Yeah.
great precision. And it turns out the moon is receding at 3.8 centimetres per year.
And what can they calculate if they know it's going that far?
Well, first of all, that's not very far, right? That's 3.8 centimetres about.
Only 3.8 centimetres.
Right. Okay. Now you think, yeah, that's nothing. But it actually isn't just nothing, because as the moon recedes,
Yeah.
what's happening is that the Earth is actually slowing down. It's because of that tidal locking mechanism that I talked about before.
Yeah.
Only it's the effect that the moon has on the Earth. Now, you can wind this process back. So the moon's receding from us. So if you go backwards in time, it must have been closer to us.
Of course.
All right? And you can wind it back and wind it back. And how close can you actually get? Well, you can't get closer than what's called the Roche limit. And that's the point where the gravitational gradient over the moon would be so great it would tear the moon apart and the moon couldn't exist. So there is a limit to how close you can come.
Would it fall back down to Earth then?
It would just disintegrate and the bits would probably be in orbit, and maybe they would.
Okay.
But the thing is this, it would only take about 1.5 at the most, some people think about 1.3 billion years for that to have happened. So if you wind it backwards, you can only go back 1.3 billion years, and it can't be older than that. Now, here's a problem, because we're told that the Earth-Moon system is 4.5 billion years old. So it's barely a third of the age that the secular scientists need to have.
That's a problem.
So it's a problem. Now, they've looked at that and thought, what do we do about this? Well, part of the mechanism by which the Earth is slowing down is that it's dissipating energy. And scientists think, well, maybe there are ocean resonances, say, across the Pacific between the east and west coasts, or the Atlantic, or maybe the Indian Ocean, and that these resonances are dissipating a lot of energy. So the rate at which the moon is receding now and at which the Earth is spinning down is much greater than what it was in the past. Now, you've got to remember, science is all about making observations in the present. Scientists can't observe things in the past.
Okay.
So they make up stories about the past to explain the present. But it's storytelling. And when you make up a story, it will always reflect what you believe happened in the past. Right? Now remember, these guys are saying there's no God, we must explain everything naturalistically. So they're stuck in this bind. How do we account for this mechanism only giving a life of 1.5 at the most billion years? So they're trying to explain how it might be that the moon is receding much more rapidly now than it was in the past.
Yeah.
Because remember, they're trying to claw back time. They need 4.5 billion years.
It's a lot of time to get.
And all they've got's 1.5. They're a long way short.
Yeah.
So it must have been some mechanism whereby the process slowed down, and now we see it happening quicker. Now, the argument was some kind of ocean resonance. In fact, some have even suggested that maybe there were no north-south continents on the Earth, and there were no ocean resonances, and it was ocean all the way around the equator. Now, that's a pretty wild assumption, because if that was so, then the ocean currents around the equator would be travelling at a huge speed, causing enormous damage and erosion to land masses. And by the way, none of the plate tectonic models fit that kind of scenario.
None of them.
None of them.
Okay.
So they're caught between a rock and a hard place, if you like, over this energy dissipation thing. But they're still trying, all right?
Caught between an Earth and a moon.
An Earth and a moon. But there's one other thing I didn't point out that I need you just to explain, because someone is bound to jump onto their calculator and say 3.8 centimetres a year for 1.5 billion years, that's only about halfway between the Earth and the moon. Mark, you're mad. So, and the difference is this, it's a very non-linear process.
Explain non-linear.
Well, a linear process would be just a steady progression at the same rate for 1.5 billion years.
Yep.
But what actually happens, let's turn it around the other way, if it started out close, it would recede rapidly at first and then slow down. Very rapidly. In fact, the rate of change goes inversely as the sixth power of the distance between the two. And that happens to be really fast, right? So it starts very quickly and slows down.
Yeah.
So what we're seeing is the tail end of this. That's why it's only 3.8 centimetres a year. Earlier on in this assumed process, it would have been going far faster because the energy dissipations and the gravitational effects on the moon would have been vastly greater.
Okay.
So therein lies this problem, and there is no solution for it. Some people try and gloss over and say, oh, no, if you do the mathematics properly, there are acceptable models that explain a stable Earth-Moon geometry for 4.5 billion years, but there's not. That's just trying to muddy the water.
Okay. And so are there any other evidences that we can observe today that suggest a recent creation?
Yeah, there are. Look, the surface of the moon, for instance, has these things called scarps on them. Yep. These are like abrupt changes. We find them here on the Earth. You'll have an escarpment where you have a high plateau and then a cliff and a lower area. And it looks just like one part of the crust has been lifted up. And these are quite clearly recent because the cratering around them shows that, well, let me wind back. If there had been an old crater and the scarp had happened, right, you would see that crater partly obliterated if it was right where the scarp was. And that's what is observed.
Yeah.
So there were some craters there. The scarp, this uplift, has partly filled it in. Subsequently, there have been impacts on the scarps, which indicate that there's been impacts after them. So these things are happening in relatively recent past. Yeah. And what it suggests is that the moon is still cooling and the crust is contracting. So as it contracts, you get these geological effects happening and a slip happens and this scarp occurs. So that's very interesting because it's telling us that the moon is still cooling. Now, if you think about it, it's only 1/80th the mass of the Earth. It's pretty small. And if it's been around for 4.5 billion years, even if it started out molten, it should be a solid lump of rock by now.
So it should be dead.
It should be dead, geologically dead. You shouldn't be seeing geological activity taking place. But there is. There are things called transient lunar phenomena. These are things that occur very briefly, consequently quite hard to measure and observe. People see things like flashes that occur. They see mists or clouds that appear and then dissipate. And interestingly, Apollo 15 registered the presence of a radioactive gas called radon, 222 rather is the atomic number, which is an unstable form of radon. It decays very quickly, has a half-life of only 3.8 days. So that means it's not going to stick around for very long. So just when the Apollo 15 modules were on the surface of the moon, they detected this stuff, which must have only been around for a matter of a few days. So that says there was some kind of recent geological activity.
Amazing.
So we see a geologically active moon, but that's not consistent with an age of 4.5 billion years. Another fascinating one are ghost craters. Remember we talked about these lunar maria, these large black areas of solidified lava, which are hard and flat. Now, ghost craters are faint outlines of a crater. You can just see the circle. It's like the edge of the crater just poking up through the lava and it's all solidified.
Okay.
So it's not a deep crater. So if you think about it, after the lava has solidified, if there was an impact from a meteoroid, it would have left a crater. And we see nice, clear, small craters on the maria.
It would have broken it.
Yeah, but they're no big deal. They're just like the craters on the other side in the rocks. There they are, hitting a hard surface. If there'd been an impact before the flow of lava, then the lava would have simply filled it in and you wouldn't see it. So the fact that you see ghost craters suggests that the impact occurred before the lava had hardened. So how long does it take lava to set? Well, depends on how much and all those sorts of things. You might be able to stretch it out perhaps to a year, but more likely months or something like that. we see volcanic eruptions happening on the Earth, and it's not long before the lava is solidified.
Well, surely not long.
No, not long at all. Like you see volcanic eruptions on the Earth, the lava flows, and it's all hot and liquid, and then it sets, doesn't it?
Yeah, well, you see pictures of it all the time.
That's right.
That black basalt rock.
Yeah, and it becomes basaltic rock. Exactly. So these maria would probably have solidified, maybe being generous, perhaps a year or something like that. And yet these ghost craters are present. So that tells us that the craters occurred while the lava was still molten. Now remember, the evidence points strongly to this all happening very rapidly. And so you think, well, hang on a minute, that tells us that the rate of cratering must be quite high. There must be quite a few frequent impacts happening all the time.
Yeah.
Now, the secular model is that cratering is quite rare, that it happens very slowly. So if I were to look at a moon or a planet and count the craters on it, if I assume it's a very slow cratering rate, I'll get a very old age for that moon or planet, right? But if the cratering rate is much faster, then those things would be younger. So can you see how it doesn't play into the secular model of billions of years?
Okay.
Cratering rate's too fast.
Well, especially if it's hitting magma.
That's right, hitting magma and leaving ghost craters. And there is not just one or two of them, there are a lot of these. Now, bear in mind, the secularists are very, these guys are clever. They're trying to understand why things are the way they are. But remember, they're locked into a paradigm that won't allow a supernatural creation. So they're forced to find naturalistic explanation. So this is a big puzzle, all these maria on one side and not on the other.
Yeah.
So with the aid of some very clever measurements of the moon's gravitational field, they've discovered that the crust on the far side of the moon is about 20 kilometres thicker than the crust on the near side of the moon.
Wow.
And they say, that's the answer to why there are maria on our side but not on the other, because the crust is so much thicker that it survived the impacts without shattering and without releasing all the magma, right? So you don't get these lava flows on the far side of the moon. But an alternate explanation is that this face towards us, got so pounded that the crust was so mashed and so much lava came out that it hasn't had time to recover properly. And remember, according to the Bible, this happened probably about 4,500 years ago, likely at the time that the flood was triggered. And the flood occurred about 1,600 years after the creation, according to the Bible's timelines. And that makes a lot of sense. So you have a rapid, relatively recent bombardment, and it's on the face that's looking at the Earth. Now think about this. So there's the moon, we're looking at it. These things have hit that way, we're looking at the side. So they must have come from behind the Earth, probably hit the Earth, right?
Yeah, hit me in the back of the head.
Hit in the back of the head, exactly.
That's right.
Except that, and you would think, therefore, there should be ample evidence of large craters, massive craters on the Earth.
And do we have those?
And we do, but they're not on one side.
Okay.
They're distributed. The reason being, of course, that the Earth spins much faster than the moon. The moon's very slow. Remember, it takes 27 days to turn once. We go around once a day. That's what a day is.
Yeah.
So if this bombardment lasted a day, say, it would have still distributed massive craters all around the Earth.
Amazing.
Now, there's a great video in this series done by Dr Taz Walker. And he talks about cratering on the Earth and the moon and some of the large craters we find on the Earth. Now, just think, the impact on the Earth's crust would have been absolutely devastating. And some biblical creationists, I'd be one of them, would argue that that was likely one of the triggers that started Noah's flood by fracturing the plates, what we now find as continental or tectonic plates on the Earth, at the initial part of the flood when the fountains of the great deep burst forth. Maybe these two things are correlated. Makes a lot of sense to me.
All right. And are there any other evidences that could point towards a recent creation?
Yeah, there is. One more, which is interesting. The Apollo missions, I remember I said brought back rocks. And so in the analysis of those rocks, they've discovered that there was a past very strong magnetic field on the moon. And that's pretty perplexing because today there's virtually none. So the secularists have thought, how could the moon have had a significant magnetic field? In fact, it appears to have been stronger than the Earth's magnetic field is today. Stronger. So it was quite something. So the view today, from the secular point of view, is that magnetic fields are supported by large circulating currents inside a planet or a moon.
Yeah.
But to have a circulating current, you need some medium for it, and they need to have large bodies of molten material in the mantle of the planet or moon, and you need a fairly fast spin rate to keep sustaining a current which will sustain a magnetic field. So the Earth, for instance, is supposed to be 4.5 billion years old. Its magnetic field has presumably been around that long. There's evidence that there have been many reversals. But to sustain it, how does it keep on keeping on? Because if it's just a single current, that will decay in time. It'll run down.
Yeah.
Does that make sense? Because things always run down, left to their own devices. They're like a spinning wheel. It just gets slower and slower. You've got to spin it up again if you want it to keep going.
And so does the magnetic readings that we have on those rocks indicate that it was only 6,000 years old? Or
no, what it indicates is that the magnetic field was once very strong, and if the secular model's true, there must have been a very strong current.
Yeah.
But here's the problem. The moon doesn't have a very large molten mantle to support such a current, and it spins far too slowly. Once every 27 days is not enough to keep a circulating current going for 4.5 billion years, or anything like it, in fact. So there's no practical solution to that in the secular model. But from a creation point of view, it's perfectly reasonable that God could have created the moon with a magnetic field, which has now decayed away over 6,000 years.
Makes sense.
So once again, it's a challenge for the secularists. Now, but just bear in mind here, we're not trying to prove the Bible with science, as some people think we do. If I was doing that, it would be like making science the benchmark and testing the Bible against it.
Yeah.
Right? But it's not like that. The Bible is God's word and it's the truth. So it's the benchmark, and we use the Bible's record of history to interpret the evidence that we see in the world around us.
Okay.
So that's why when we look at the evidence, we see it makes a lot more sense in the context of a recent creation, and a creation that shows evidence of purposeful design.
So we've covered a lot of ground today talking about our amazing moon. We've seen clear evidence of design, evidence of a rapid process, failure of evolutionary models to explain the moon's origins, even though we've walked on it, and unmistakable evidence for a recent creation. What are our takeaways for today?
Well, I think the big takeaway is that the evidence in the world around us points to a creator, God.
Yeah.
And there are things that prevent people from believing in God. You know, in Hebrews chapter 11, verse 6, I think it says, without faith, it's impossible to please God.
Yeah.
Anyone who comes to God must believe that he exists.
Okay.
And that he rewards those who diligently seek him. So the evolutionary story basically tries to explain the universe without God. So the more it's presented in our culture, the more people, it sort of soaks in, you know, and you think, well, maybe there's no God. So how can you come to a God whom you're not even sure exists? I mean, there are lots of stories where people do. They say, God, I don't know if you exist, but if you do then, and God honours their prayer. But you see, it becomes an intellectual barrier. People, they just won't even consider Christianity because they believe that science has proven that the Bible is wrong. And if that's the case, then that becomes what in 2 Corinthians it says that we demolish arguments and every pretension that sets itself up against the knowledge of God. Yeah. And evolution is just such a pretension because it shuts people down from even considering that there is a God. So the message from the moon, I think, is that the moon is an example of God's creative handiwork. It's an example that of the truth of God's word. which describes what God did in the creation week. And that means that we can have confidence that the Bible is actually true. So what does the Bible say? Well, it says that we have a choice to make. And how we respond to that choice is going to determine our eternal destiny. Because mankind rebelled against God, we've cut ourselves off from him because of our rebellion, or sin as it's called in the Bible. But God has made a way for us to come back into relationship with him. And it's through faith in his Son, the Lord Jesus Christ, who gave his very life for us because he loves us so much. He wants to be in relationship with his creation. And the Bible says that it's by faith that we can be born again, renewed, receive God's Spirit, and be in a relationship with our Creator. And that's an awesome thing. I look back on my own life and I realised that it was just transformational for me to know that I could be in relationship with my Creator and that I have an eternal destiny with him. So the message of the moon is consider that there is a Creator God and consider how you will respond to the truth claims that he makes.
Yeah, wow, Mark, that's amazing. Now, Mark, a little bit earlier we spoke about one of the resources that we have available at Creation Ministries that helps explain evolution and the science behind it. Can you introduce that product for us?
I certainly will. And we did talk about this, and you told me that it had a very important part in your faith journey.
Yeah, indeed it did, because I was a theistic evolution believing. But unfortunately, the science just didn't add up. The more I looked into it, the more holes it was in. And it was actually thanks to this. I must have watched it at least 7 times.
Wow.
Until I started to actually get the science behind it, because I am not an intellectual. You know, I work in the gardens, but the science, when it was articulated simply, there was too many holes.
Yeah.
And it just gave me a greater understanding and a greater faith to believing in God's word as it is, and not as sometimes I want it to be.
That's fantastic, Matt. I'm sure a lot of people will be impacted just as you were.
Yeah.
So the product is called, of course, Evolution's Achilles Heels.
Yeah, and we're going to make this available on the website for up to 7 days for free, isn't that right?
That's right.
Well, thank you very much, Mark, for being with us today and having these discussions. It's been an absolute pleasure.
And it's been great fun doing it. Thanks, Matt.
God bless.